welcome back. We are continuing the discussion of spatial query languages, and this is the second video in the sequence. You have already seen what a query is and you understand what a query language is. So now we'll continue our journey towards SQL, and in this video segment we are going to do two things. First, we'll introduce a simple database with 3 tables. So at the end of this segment you should be able to understand what those 3 tables are, what are the columns in there, and what do the rows mean. The second objective is to introduce a SQL overview or in a big picture. So we'll essentially talk about 3 main parts of SQL so that we kind of know the location of the future videos. Okay. So let's get started with the database. So we are going to introduce a simple database with 3 tables which represent some basic geographic facts about the world. Okay. So in this database there will be 3 tables or at conceptual level 3 entities. We'll talk about countries of the world, cities of the world, and rivers of the world. These 3 entities will be connected via 2 relationships. The first is capital of. So cities and countries would have a relationship where certain cities may be capital of specific countries. And the second relationship is originates in. The rivers and countries will have this relationship. So for example, you may say Mississippi originates in USA and so on. Okay. So this database can be viewed at a conceptual level using an entity relationship diagram, which is shown in this slide. In this diagram we are using Peter Chen's notations, so where entities are represented as boxes. So the 3 entities we just introduced, they show up as 3 boxes in this picture. So you can see on the left a box named city, in the middle a box named country, and on the right a box named river. So these 3 are the 3 main entities or the tables in your relational database. The 2 relationships we described, capital and originates, they show up as diamonds. So you can see a diamond connecting city and country and another diamond connecting country and river. Okay. In addition, you also see a set of ellipses in this diagram, and they specify the attributes of entities. So for example, the city has 2 attributes and so on. We'll very soon show you the details of these attributes at the tabular level. Okay. So the same database, now we are going to view it as a set of tables or logical data model in a database. So these 3 entities become 3 tables. So country entity is represented as country table, which has a set of columns such as name, continent, and so on. We are going to show you the table in the next slide, so I'm not going to go over all the attributes right now. The other 2 tables are city and river, and again you notice those attributes show up as columns in the table, and in following slides we'll show you the detail. Now in relational databases we also specify keys. So some columns are designated as primary keys, and they essentially mean that if I look at a table, these columns would have unique values across the rows, and very soon we'll be seeing this table. Okay. In addition, databases also talk about foreign keys, and they are often used to represent the relationships. So the capital of and originates in, those are modeled via these foreign keys, and we'll show that soon. Okay. So let's look at these tables in more detail. Here is the country table. In this country table you can see 6 columns and several rows, right. So first column talks about Canada, and it is in North America continent and so on. The columns of the table are described next, and you notice the columns like continent, gross domestic product, population, etc. For the spatial database, the last column is of particular interest, and in here it is simply shown as column name shape, but in each row you notice some polygon ID like polygon ID 1, 2, and 3. We are not actually showing the entire geometry here, but at a high level you can understand that they are representing the boundaries of respective countries. Okay. The next table is city table. Here again you see different columns specifying the attributes which are described here. You have population and so on. Again, the last column is of special interest in the geographic database, and it is describing the geographic location. So if you imagine the city center as a point, perhaps this is describing the latitude and longitude of that point. Once we have such spatial columns, we can use those to pose geographic queries based on distance or inside and outside kinds of relationships. The third table is the river table, and again you see multiple columns, and the last column is a shape. In case of river, we are looking at the center line, so rivers are being modeled as a line string. The other columns are described here, where you have name, the country of origin, and so on. Okay. So these tables will be used in all the follow-up examples of SQL queries, but before we get there, we are going to provide you a big picture of SQL. Okay. So let's talk about the SQL language. Okay. What is SQL? So SQL is an acronym. In 1980s, people did have more specific complete name. Some called it structured query language, others called it standard query language. But since then, most of us actually have forgotten what the actual name was, and it's typically called SQL, or colloquially you can call it SQL. Okay. But it is very popular. If you are in relational database world, almost all relational databases understand SQL. There may be slight variations in terms of from vendor to vendor, but it's an intergalactic data speak. Okay. One way SQL is different from other programming languages is that it's a logical level language, or some people call it declarative language. So in other words, in SQL we describe what subset of data needs to be retrieved, but we do not give a detailed algorithm. We do not give a step-by-step algorithm. We do not say whether we have to sort the data or index the data. Those are all hidden, unlike other programming languages such as Java. So if you were in Java or Visual Basic or C++, in order to extract a subset of data, you will have to specify the algorithms and data structures in addition to the subset, whereas in SQL we do not do that, and databases are responsible for figuring out the algorithms and data structures. So SQL is a rich language. You can specify a very, very rich set of queries in this, and as we proceed with the detail, you will see those examples. Okay. All right. It is supported by all database vendors, and you are seeing some names here from IBM, Oracle, Microsoft, Sybase, and so on. And there are a few different versions. The first version starts with 1986, often called SQL 86 or SQL 1. A major revision came in 92, sometimes referred to as SQL 2. And the version of most of interest in our discussion is SQL 3, which started in 99 but was formalized in 2003. Since then, another major version was released in 2008. But essentially, starting SQL 3, there is provision for user-defined data type, and using that provision we can add geographic data types such as points, polygons, line strings that we saw in our tables. So most of our discussion will be post SQL 3, so either SQL 3 or SQL 2008. Okay. So how do we use SQL to manage spatial data? And essentially early 2000s this trend started. Most geographic information systems did have a database in the back end. Till early 90s, those used to be custom databases. Around mid 90s, it opened up through ODBC bridge, where any other relational databases could be plugged in. And starting 2003, we also had all the geographic data types. So ESRI, which is the major player in geographic information system, they have their own database, but they can also use databases from Oracle and so on. So, so the main point here is that even though in geographic information system or mapping software like Google Earth, you may not see SQL upfront, you may only see a graphical user interface, but in the back end they all have these databases. Okay. All right. And in those situations, the SQL queries that we will study are often generated by the front end software. They are not always written by a person. But even though that is the case, but in this course we will try to understand what those queries look like and how we can write those by hand. Learning that skill is still valuable for two reasons. Okay, number one, as if you are into technology, then you would have access to SQL system and you will be able to write those queries yourself. Second, even if it is being generated by application software, once in a while the query generated by application software runs very slowly. It takes forever, and at that time a human expert has to go in, read the query and try to understand are there ways to speed it up. So again, the skill to read SQL query is an important skill. Also, the ability to be able to change it to speed up performance or the semantics of the question is an important skill in today's job market. In fact, a recent survey, 2014, when they listed the most popular language in industry for the jobs, SQL was among the top 10 languages. So, it still continues to be a very valuable skill. Okay. So, with this, let's go under the hood and at least take the first look inside SQL. Again, SQL is a vast language. It has many statements, but at a high level you can group them into three parts. The first major part is the data definition language, and this provides us with a set of statements to create tables and also to change the definition of the table. This is equivalent to defining classes or a struct in Java. Essentially, the idea is to define the table names, their columns and so on, and the data types. Okay. Once these tables are defined, then we use a second module of SQL called data manipulation language. And in here lies the statements to, for example, add data to the tables which have already been defined. And once you have added the data, there are statements to extract subset of the data or change the data or delete the data. Okay. In our course, I think we will touch a little bit on the data definition, how to create or define a table, and then how to insert data, which is data manipulation, and how to query. There is a third part which we are not really going to look at in great detail. It is called data control language, and these are used to, for example, set security permissions, which user can see which tables, or they are also used to specify transactions. So, if you wanted to group a set of updates as atomic unit and so on, those are in this part. And in our course, we will not really talk about it. So, our focus primarily will be a few statements from data definition and few from data manipulation. So, with this we complete our basic introduction to SQL. In the following video, we will come back and delve into the detail of data definition language and data manipulation language.